Good afternoon, everybody. We're just going to thanks for being on time. We're just going to give everyone a couple more minutes to join, and then we will get started.
Well, and of course, good morning to everyone who's out here on the West Coast.
Yeah.
Feels like we should have some dramatic story to tell here while we wait these last couple of minutes.
All right.
Be careful not to talk football.
I think we can probably get started now. Good afternoon, and I want to thank everyone for joining us on our call today. My name is Christina Spearman from Transcat, and I'll be your moderator this afternoon. Our webinar topic is Pinpoint the Leading Causes of Downtime with the LinkIQ Cable and Network Tester. This topic is being presented by Jim Davis from Fluke Networks. Jim has been working in the cabling industry for over 25 years, with Fluke Networks for more than 20 years, most recently as a regional marketing engineer. Prior to Fluke, Jim spent almost 10 years with Annixter. Jim is the chair of TIA's FOTC membership committee. He has participated and consulted to different standards committees, as well as being a frequent presenter at trade shows and webinars. Jim's objective is to bring the experience of the industry, market, and the lab to you and present it in a way that the common user can understand. We expect today's presentation to last roughly 30 minutes, and then we'll answer any questions that have been submitted. During any time during the presentation, you can send questions through the question box to the right in your webinar controls. I also want to mention this webinar is being recorded. Each of you will receive a follow-up email with a link to the recorded webinar and the slides of today's presentation. At this time, I'm going to turn the presentation over to Jim.
All right, Christina, thank you very much. As I mentioned, good morning, everyone. I'm coming to you from Seattle. I hope everyone's having a good day, and I really appreciate your time. I'm going to try and make this as worthwhile as possible. We are excited to have this new tester, the LinkIQ, and I wanted to walk through some of the features and some of the common network problems that we can solve with this. Please, if you have any questions, go ahead and send those in. That will make our question and answer session a lot more interesting. So, hey, big surprise. We make cable test equipment at Fluke, and we talk to our customers to try and find out, people running networks, network engineers, network owners, what are the causes of problems that they find. This is actually the result of a survey that a company had done, and no surprise, it's the cabling, the connectors, the cable, too long. We're giving EMI as a cable failure as well. Now, this isn't going to be a surprise for anyone, except perhaps that the numbers are so low, because if the cabling is not the cause of the problem, it certainly is suspected as being the cause of the problem. What are the common questions? I'm going to try to paint a picture for you of a technician who has been sent to solve a network issue, any network issue, make it up. I can't connect, the network's slow, I need to add something. Wireless access, the wireless coverage doesn't seem to be working well on the far end of the building. And that's good, because the facilities guy who we're going to send to take a look at that wireless access point also has to fix the back door. It's been sticking. Grease that so it doesn't get stuck. So he has a lot of responsibilities, not just networking. So he goes there and he looks up at the ceiling, and there's the wireless access point. It has no lights on. He climbs up the ladder, and what's coming to his mind? I wonder if this cable is good. Is the cable broken somewhere? I saw they were doing some work in the telco closet. What is the cable connected to? There we go. That's how you can tell this is going to be a live demonstration. What is the cable connected to? Is there a switch on the far end? Which switch is it? Is there a problem with that switch? Oh, come back here. There we go. It's why is the connection not working? Am I connected to the right port in the switch? Is there a configuration issue with the switch? Is there a power issue? Maybe I'm attached to the switch, but the switch that I'm attached to is not supplying me enough power over Ethernet to drive this camera or robot or device, whatever it may be. And sometimes, how am I going to document this trouble? Sometimes you just solve it and you're done. But if you had to travel, if you were on the road, your boss might want a piece of paper that says, here's what I did and here's how I fixed it. We're going to try and address all of this with our new LinkIQ. And here is a nice picture of the LinkIQ and our first pain point, our first question, is the cable good for this application? We just bought a new Wi-Fi 6 wireless access point, and it's going to give us gigabit speeds to multiple users. Is the cable going to support that? Well, remembering that our technician, he's still up on the ladder, sorry about that, has a lot of work and is not necessarily a networking infrastructure specialist, this is real easy to understand. Pass, the cable's good. Here we can see that the test has been set with a test limit of 2.5 gigabits. This cable's so good it'll even support 5 gigabit speeds, won't get up to 10 gig. Very simple test. If there is any problem with this cable, there's an open conductor, a short, perhaps a split pair, we'll tell you that. We'll tell you the distance to where the cable might be open. And finally, this fun bandwidth speedometer. So what is a bandwidth speedometer? We are not certifying this cable. We are not going to test and see if it's category 5 or category 6. But what we're testing is what speed can an application run on this cable? Now, these things are a little bit different. I'm going to try and explain here the difference between the speed that we calculate and what we're familiar with cable categories. The TI 568 and ISO 11801 standards tell us when a cable meets the requirement of category 5E in this example, or class D in the ISO world. And really what we're looking at are different electrical parameters of the cable. How much signal is there? How much signal do we lose over the cable? And we compare that signal to noise. The noise is typically near-end crosstalk, interference from adjacent pairs, or return loss, a reflected signal on the cable. And they have pretty tight parameters because we want any category 5E link, whether it's 3 feet long or 300 feet long, we want that link to support any application that should run over it. So it's a little bit over-engineered. Now, the IEEE 802.3 standard, that's the standard for Ethernet, talks about the different connection speeds and the requirements to make a connection. And it turns out that we're probably not going to use all of the available bandwidth in that category 5E cable. We can see here what I'm trying to represent is this blue part of the cable is what we require to run gigabit, but category 5E offers us more. So this is not a certification tool. We don't comply with the TI 568 standard, but we will tell you if your cable will support gigabit or even 10 gigabit Ethernet. Now, just because we say that a cable will support 10 gigabit Ethernet, that does not mean that it's a category 6A cable. Now, let's go to a trusty Venn diagram here. In the universe of links that will support 10 gigabit speeds, all of the compliant category 6A links will support 10 gigabits, but there are some category 6 and some category 5E links that will also support those higher speeds. Okay, so we know that the cable's good and the outlet, the poor guy up on the ladder looks up and there's no ID on the cable sticking out of the ceiling. So he doesn't know which port of the patch panel it complies to. So how do we find that? Well, LinkIQ throws in our trusty tone generator. And let's put, here is our IntelliTone. It's a really interesting tone generator because it has a port on the bottom so you can wire map out the cable after you've identified it, or any inductive probe, send a tone down the line, find out which port of the patch panel it belongs to. Now, if you're plugged into a switch, we have this useful port blink. I was just giving this presentation to the Latin American team, and I speak a little bit of Spanish, but I don't know how to say blink. So pardon my graphic here. Now, port blink light, you know which port on the patch panel you're connected to, but you've got that, I think the technical term is spaghetti, that goes from the patch panel over to the switch. It could be difficult to follow the cable over to the switch. So what the port blink will do is cause that little LED on the port of the switch to blink on and off, so you can figure out which port of the switch you're attached to. Now, speaking about the switch that you're attached to, there's some different configurations that can go into play with the switch. So this is an upgrade from our cable IQ tester, and this will be familiar to people who in the past may have worked with our link runner product. And that is, we're going to tell you which switch you're attached to, at least confirm that you're attached to an active device on the far end. And most modern switches, maybe not your home Ethernet switch, but most modern corporate switches will tell us the port of the switch we're attached to, its name, and the VLAN information. Now, this can be very helpful because our port technician, still on the top of the ladder, he can call into the network operations center, might be in the same building, might not even be in the same country. And those network engineers in the network operations center can reach out to the switch remotely and take a look. What's the switch doing? Does it have PoE turned on? Is PoE capable? What VLAN is it in? And are they getting errored frames? Different information. So this can be very helpful. Also, some real simple stuff. It will tell us what speeds we can connect at. Can we do half or full duplex? We were talking about this fancy new wireless access point. It can connect at 10 gig, but this switch port isn't capable of 10 gig. Or perhaps the last network administrator went to a presentation where they said, make sure you lock down and don't let your switches auto negotiate. And if your switch port is fixed at 10 megabits, that might explain why it's not going faster than the old switch. Just two words about VLANs, and I don't want this presentation to be too deep, but I want you to be familiar with what is a virtual local area network. A VLAN is a way that you can easily segment the network traffic. So typically on the network, when you start to have a lot of devices, there is a lot of overhead. There are broadcasts and multicasts. There are people trying to send a ping, people trying to resolve addresses with ARP or with DNS. And as you get lots and lots of devices on the network, you start to get a lot of traffic that you don't necessarily want to share. So you can segment your switch into these different VLANs and keep traffic together. In this example, I've got the wireless, all the wireless access points are on one network. Hey, I want to make the network available to my technicians so they can, I know they're going to check on Facebook and maybe they'll send a text message home during the day, but I don't want that traffic to get in the way of my production network. My production network is very time sensitive, deterministic. And if there's extra unexpected traffic, that might slow down my OT network. So I want to make sure I keep that separate, and I could divide it any other way. Might be by people in the accounting department, people in HR. In this example, security cameras. Now the trick is, from the outside of the switch, you can't tell which VLAN the port belongs to. Now, making sure that you're connected in the right VLAN, this isn't going to be necessarily earth-shattering unless your device is slowing down the OT network. So, hey, this is just one more simple bit of triage we can start to do before we break out the protocol analyzer and do time-consuming, difficult stuff. So we're finding more and more people are using Power over Ethernet. Power over Ethernet is practical because I don't have to send a second conductive path to my device. I don't have to have an outlet for it to plug in on. I don't have to have a second DC converter out there on the floor heating up and wasting energy. I can supply DC power over the existing Ethernet line. Now, because this is new technology, we find that not all of the Power over Ethernet is the same. I'll talk in a little bit more detail on PoE in a moment, but what we're seeing here in LinkIQ is we are negotiating with the switch and we're saying, how much power can you supply me? And then we're doing a load test where we say, okay, if you're telling me that you can supply me 13 watts of power, class 3, give it to me and let me make sure that I'm receiving it. Make sure there's not a problem with the cable, or perhaps the switch is oversubscribed and it doesn't have that much power left. So I really like this table to help explain sort of the different flavors of power over Ethernet. Over the last couple of years, we came out with lower power levels that are good to power a voice over IP phone, the 802.3 AF, then the AT standard came out that gave us 25 watts, and more recently, the 802.3 BT standard has been published. So what we see here, the power sourcing equipment, typically a switch or an inline power supply, transmits a given level of power, and we lose a bit of power as it goes down the wire. And at the powered device, here's the amount of power we're going to receive. Well, my fancy new wireless access point with multiple radios to go really fast might need more power than the old device that was here, and the switch may not be capable. I say, hey, switch, I need class 5, I need 40 watts. And the switch says, no hablo 40 watts. What do you mean? I came out in the 802.3 AF. This is all the power I can supply. So real simply, we could see, hey, the wireless access point's working, the cable is good. This switch port perhaps is configured not to offer that much power. All right, so we need to document this. Now, I'm always going to recommend that when people install cable for the first time, they use a cable analyzer, a DSX 5000 or a DSX 8000, to certify that the cabling meets the standard. The standard is the best guidance of the industry. But I appreciate that not everyone is going to demand certification. Not everyone is going to pay for certification. I'm going there installing a new sandwich shop, and the sandwich shop needs 5 network drops, a camera, a cash register, something else, and they're not going to pay for certification. I might use a Cable IQ or now our LinkIQ, which can test up to 10 gigabit, to check and make sure my technicians wired at least have the wire map correct. And if it tells me that all the cable they installed will support gigabit, that's great. My sandwich shop only has a DSL dial-up, a DSL connection. They're not going to be sending 10 gigabits of data over the wide area network. Now, after I run these tests, I can save the test results, and LinkIQ works with our Linkware software, the same software that you're using with your DSX 5000, your DTX 1800, your DSP 4000. It all runs on the same software, which works real nicely to manage the test results. Okay, for those of you who are familiar with some of our other products, this chart is just a simple comparison to help you locate what the capabilities are. The micro scanner, the new version, the MSPoE, is real good for doing wire map. Do I have continuity? You know, with an 8-conductor cable, there are like 40,000 different ways to wire it wrong. We're going to check all of those. We'll tell you the length to where it's open. We can tone it out. It does not save test data, and it doesn't tell us anything about the switch. It will tell us that there's a switch out there, but nothing about its capabilities. Many of you may be familiar with the Cable IQ. This has been out for over 15 years. And this is a product that, again, is measuring signal strength and noise to check if a piece of cable can support a given speed. Can it support 10/100? This goes up to gigabit speeds. 15 years ago, we didn't have 10 gig. Notice that when you save results in Cable IQ, you have to use this kind of funky Cable IQ reporter software. Now, as we step up to Link IQ, hey, PoE has also advanced in the last 15 years, so we're fully compliant all the way up to Class 8, 802.3 BT. We can save those test results in Linkware, test up to 10 gigabit, and give you information, that useful information we used to get from the link runner. Hey, which switch are we attached to? Now, I want to differentiate this from our cable certification tool. As I mentioned, the guidance of the standard. That is the experience of the industry. If you're installing new cabling, you really want to certify that, and the DSX is the only one that will certify to category 5E, 6, 6A, even category 8 test results. Okay, now the exciting part of the presentation, and the reason you're coming to a live presentation instead of watching a recorded video, I'm going to try and give you guys a little demonstration of this working. So we will just, well, maybe we're not going to stop sharing our screen. There we go. I'm going to give you something else to look at. Bear with me one second. What I'm going to give you to look at is not this presentation. There we go. But our trusty little workshop here. Hello, by the way. Sorry, I'm not showing my face here. My efforts to get a camera on the tester and have it working take up all of the facilities of my computer, and I don't want to overwhelm it. Now, just for fun here, while I was doing that first bit of our demonstration, our trusty system decided to stop. So let's get this running again, and let's just connect to our trusty tester, because what I'd like, there we go. So sorry about that, just stalling for time. I want to do justice to this product, and as I mentioned, this is the daring part. This is the up here on the high wire with no net. So here is our LinkIQ. If you've never seen one before, pretty simple tester. It has one port, and I'm going to plug the cable into the one port. It has a USB C port to connect to download those test results to Linkware. And the first test that we're going to do here is to an open cable. So I'll just push auto test, and it says, wow, I see a cable. Let me tell you the distance to where that cable is open. And you can see my communication from my screen to my computer is a little funky today. But what it's showing us is that this cable is open about 6 feet away, 1.7 meters. Great. I'm going to hit save because I want to save this test result. So I'll put in the cable ID, click OK. Great, the test result is saved in the tester. And now, in order for me to qualify the speed of the cable, I need to put one of these little terminators on the far end. This will also help me to make sure that I don't have an open conductor here at the far end of the cable. Now, a single one of these comes with the basic unit, but there are 6 of them. So when you're going out and cabling up that sandwich shop, you could put a different ID in each one of the outlets when you go to the patch panel and identify where they are. Since I have a plug on the far end, I'm going to use just this little coupler to plug in my remote identifier. We'll push test, and hey, there we go. We're running our test, and there we go. Now I've selected a speed limit here of 10 megabits, but no surprise, my 5-foot cable would support 10 gigabit Ethernet. There's almost no signal loss. So the signal to noise ratio is skewed very heavily towards the signal being good here. All right, this one's ready to go. We're gonna hit save. And now let's take a look at something a little bit different. I don't know how many of you operate in an industrial environment, but we're finding Ethernet gaining much more use in industrial environments. And in an industrial environment where I may have vibration and dirt and water or other liquids spraying around, our friend the RJ45 plug is not necessarily the best solution. So there are more heavy duty connectors that we'll find in the industrial world, such as this M12 decode connector. Well, if I'm using a decode connector, I can't plug my remote terminator in here. So we've come up with this interesting remote adapter that allows us to terminate, yes, on an RJ45, but on an M12D for data, an M12X, X for 10, a 10 gigabit connector, and even a smaller M8 connector. So bear with me a minute because this is a little bit more heavy duty. We've got to work to get this. Oh, come on. There we go. And let me just screw this in here so we can get the termination on the far end. And also, hey, if you haven't seen an M12 connector before, I'm sure you'll be fascinated to see this more heavy duty connection. I've got an adapter cable here that goes to an RJ45, and we will push test, and hopefully, dramatically, it will pass. Now, the decode connector only has 2 pairs, so it can only support up to 100 megabit Ethernet, transmitting on one pair and receiving on the other pair. Because gigabit Ethernet uses 4 pairs, this isn't going to support gigabit or higher speeds. Now, we see that those other conductors are open, but I only need to do 10 megabits, so we're in good shape. Anyways, there is our industrial test adapter. All right, and we'll save that test result because got to show the boss we were busy while we were out here. Now, let's take a look at what happens when we plug into a switch port. You'll notice that I have 2 switches here. Yeah, I'm in my house, so I don't have the world's fanciest network, but this will certainly be good enough for us to show a couple of different situations. This is where I should ask for audience participation and see which port I should be plugging into. Hopefully this is the port that you're asking me to plug into. There we go. And we'll push test. Now, one of the interesting things is LinkIQ figures out on its own, hey, I'm attached to an active network, so let me do my active network test. And here we can see that it's telling us that we are on chassis 1, slot 0, port 9 of a switch named Marysville. Okay, Marysville, of course, being the town north of Seattle where I am, not that original. We're seeing that we're connected at gigabit, and we're seeing the capabilities of this port on the switch. Great. Earlier, I tried to get the additional detail, and oh, it is working today. Okay, so yeah, I'm sorry, this isn't a fancy corporate network. I don't have everything configured. I'm not attached to my DHCP server, but hey, this might be my problem. Why does my switch not have an IP address? And the way that we're able to capture this information is through link layer discovery protocol. We could use that, or we could use Cisco Discovery Protocol, CDP. And this is a very, very simple test. When you plug into a switch, the switch wants to tell the next switch over what capabilities it has. So I'm barely connecting. I'm not generating any traffic on the network. I'm just saying, hey, tell me what you're capable of. All right, let's back up and save this test result. Now we're going to move on to, hey, we want to see the PoE test, right? Yes, I can hear the tremendous interest and applause out there. One thing I'm going to have to do, I'm going to go into the setup of my tester here, and you'll see that the setup is really pretty simple. Are we testing a shield? Are we allowing crossover? 568A or B? We will change the NVP of the cable. That'll help us to calculate an accurate length. Here's my 100 megabit. I chose 100 as a test limit. But what I'm going to do here is turn on my PoE test. All right, we'll go back to home and we'll push test to start. Actually, I'm going to cancel this test because I wanted to show you my other switch, because the other switch, even though it is, get in there, just it's a little home networking switch, it turns out that its PoE capabilities are more interesting than the bigger switch that I have here on my table. Now, it takes a minute for us to run this PoE test. And why is that? Well, there are the different speeds that we're going through and the different classes, and we have to ask the switch, can you do class 1? Yes. Can you do class 2? Oh, there's no answer. Well, I have to wait a timeout period to see if this will get back to me. So depending on the switch, this test might take a couple of moments to run. We're going to check for both single signature and dual signature power over Ethernet. Dual signature power over Ethernet is a situation where your end device has 2 different powered devices. For example, you may have a camera and the camera uses one of the power supplies and one power level, and you have a pan tilt zoom motor that uses a second power supply. So that would be a situation where you would be looking for a switch that has capabilities of dual signature power transmission. And that's where you can start to see how easily I got a fancy new PoE device, but it's more than my old PoE switch is capable of running. Now, hopefully that's going to be, there we go, just enough time for me to stall. And let's try and swipe this up here. Hey, it even came through. So what we're seeing is as I talk to the switch, it told me that it can do class 6 PoE, that I should be getting 51 watts of power at the powered device. So that's what it's advertising. And we're getting a green check mark because when we did the load test, we received enough power. Now, some switches that are a little bit fancier will also have a fine tuning, if you will, a software negotiation. Now, this can be an opportunity for the switch, if the switch is oversubscribed, to say, hey, could you use a little bit less power? I've got a lot of other devices asking me for power. Maybe we turn it down a little bit. But in this example, we said, hey, can you do better than class 6? Well, the switch isn't powering anything else, not a lot of voltage drop in our 6-foot long cable. And we were able to bump it up and get to class 7. Since it offered us class 7, we tested it and we were capable of doing that class 7 PoE. All right, now we're going to dramatically switch back to our other screen. Bear with me a moment, and thank you for your patience with this. There we go. And if I am not showing you a screen with models and bundles right now, somebody please, please speak up. So there's our product demonstration. Again, very simple, basic stuff, but the things you want to solve yourself. I talk about LinkIQ is kind of like going and checking the breakers in your house. I hate to call an electrician, tell the electrician there's a problem, and have him go into my breaker box and flip the breaker and say, that'll be 150 bucks. I want to take care of that simple stuff on my own ahead of time before I call in the cavalry to solve something. So what are the different models we have? The basic model of the LinkIQ is the LIQ 100. You see it comes with the tester. There's our remote ID piece number 1 and the coupler to attach it with. We have the fancier kit, and the kit is the model that we've seen the most acceptance of or the most use of. And so the kit comes with the LinkIQ. Again, we have those 6 remote identifiers. So in our sandwich shop, we can plug a remote identifier into all 5 of the cable ports, go to the patch panel, and that will help us to label each one. We don't need somebody on the far end running from port to port. This also comes with our Intellitone. This is our inductive probe. And here you can see the port on the bottom of the Intellitone where we can do the cable map test. Now, for the industrial world, we have the IE, the industrial Ethernet models of LinkIQ. Here's that terminator that can do the M series, the M12, DX, and M8. And then, of course, there is a kit that has the terminators and the Intellitone along with this interesting terminator. Just one time, here is a close-up of that industrial Ethernet adapter. Here we see the M12D, the M12X, X for Roman numeral 10 for 10 gigabits. Yes, win some bar trivia with that. Tell me what bar you're going to if that is the trivia, because I haven't found it. And here's the M8 connector is 8 millimeters instead of 12 millimeters. Oh, we also offer all of the accessories. Yeah, I know you lost your remote ID. I even know where you lost your remote ID. You left it in the last outlet that you plugged it into. And accessories, this would be the Intellitone tone and probe, any inductive probe. happy with the Pro 3000. We put a filter on this so it's less likely to detect 60 hertz hums, so it's less likely to detect power cords, it's less likely to detect fluorescent lights. And of course, if you find out that one of your conductors is open, wouldn't it be nice to have a toolkit with an ever sharp punch down blade? Hey, so you can fix that open conductor. All right, let's wrap this up before we go to questions. Cable testing you trust, network testing you need. Let's see if this cable is capable of going up to 10 gig. Let's find simple issues. Here's an open. It's 1.5 meters away. What switch am I attached to? Which port on the switch? Which VLAN? What are the PoE capabilities of the switch? And finally, let's document those test results in Linkware. We have some fun accessories out there. There's a virtual demo. You can either scan this or Christina said she's going to be sending out the deck, so you can go to this link and you can walk through the screens of a LinkIQ and give it a little test drive. Try out the buttons and see for yourself. And finally, most importantly, I want to give you Christina's contact information. Thank everyone for coming today. And now I'm going to check and see if we don't have any questions out there. It's not too late. Please send your questions in.
All
Christina, how
right.
are we doing on the questions out there?
Thanks, Jim. That concludes our presentation portion of the webinar. Like he said, we'll move into the question and answer session. Just as a reminder, if you want to send a question, send it through the question box in your webinar controls. We did get one while you were doing the demo. It says, why is there no IP address on the switch? Is it unmanaged?
Okay. Thank you for a question about LinkIQ. No. Yes, the switch is managed. My home network is a little bit loosey-goosey, and actually right now I had disconnected the switch and taken it to the factory because we were using it to record a video. And when I brought it back to my house yesterday, I didn't plug it into my home network, so it did not receive. It's not connected to my DHCP server, so it didn't receive an address.
Okay. Also another question, which model do I need to certify installs?
Okay, this is a common question, a good one. Thank you. People see this tester and they see it telling me a cable can support 10 gigabit Ethernet. We're not doing certification. The certification is more tests. It's a double-ended test. It's a more accurate test than what we do with the LinkIQ. So if you're going to be doing cable certification, then you would want to use a DSX 5000, which goes up to 1 gigahertz and category 6A, or the DSX 8000, which will test to 2 gigahertz or up all the way up to category 8.
All right, let's move on to the next one. Can LinkIQ certify if a cable is category 6?
Okay, I see a pattern here. And the answer is, yeah, still no. I'm sorry, we don't. We're not going to be able to do the certification with LinkIQ. It's just we're telling you the speed that we anticipate you're going to be able to connect at. Now, the way that we're calculating that speed is based on the requirements of the standard. The standard tell us how much signal loss or attenuation, insertion loss is allowed in the cable, and how much near end crosstalk, that's interference from adjacent pairs, are allowed. And those are the tests we use to calculate the speed, but it's not going to tell us if it's category 5E or category 6, or if it's a barely compliant category 6 or a real good category 6. For that, we'd still use our DSX.
All right. How do I download test results from LinkIQ to Linkware?
Okay. Just like, I'm going to say just like a DSX, but you don't have a DSX and you don't know, USB cable. It uses the new USB-C connector. So you'll have a laptop that's running the Linkware software. Linkware software is free. You can download it from our webpage, and it will just suck the results right out of the tester there. Now, From the Linkware software, you can convert the test results to PDF format if that's what your customer is asking for. But I always recommend that the end user or consultant or manufacturer who's going to be issuing the warranty, that they ask for those test results in Linkware format. Linkware format cannot be changed, so it gives more confidence in the test results, and it gives more detail about the test results than we would get from a PDF form. So thank you, good question.
Okay. Can I save results with microscanner PoE?
Um, a common question, what is the least expensive Fluke tester that I can use that will save test results? And today, the least expensive tester that will save test results is Cable IQ. But again, this will only tell us if the cabling is able to support up to one gigabit. The new LinkIQ will save the test results and tell us if we can do up to 10 gig. Unfortunately, the microscanner, or fortunately, either way, the microscanner does not save the test results. It'll be one of those things where you'll say, hey, this cable's open 3 feet away. Let me plug it into the wall. Oh, I fixed the problem, but you can't save that detail.
Okay, that looks like all the questions that have been submitted. So that will conclude our time for today. If you have any further questions or would like to find out more about Transcat's product and service offerings, please contact us at 800-828-1470 or on the web at transcat.com. Thank you for joining us. We hope you got something out of today's presentation and that you continue to join us for future Transcat e-learning webinars. Thanks, Jim.
Thank you. Thanks, everyone. Have a good day.
Okay, have a good afternoon, everybody. Bye-bye.